Hello, welcome back to Algebra 1. Today we're going to be doing section 14.3, Algebraic solutions of incomplete quadratic equations. So whereas we learned how to solve complete quadratic equations yesterday, today we're going to be focusing on the incomplete ones. So an equation that contains only the second power of the unknown number is called an incomplete quadratic equation. So the equation 2x squared equals 8 and 5x squared equals 16 plus 2x squared are incomplete quadratic equations. The equation x squared plus 16 has two roots, for it may be reduced to the form x minus 4 times x plus 4 equals 0, which is equivalent to the two simple equations x minus 4 equals 0 and x plus 4 equals 0. Each of which has one root, namely positive 4 and negative 4. Every incomplete quadratic equation has two roots numerically equal but opposite in sign. So let's go on to example 1. So we want to find the value of x within 10x squared equals 99 minus x squared. So we have two different methods of doing this. So let's go over the first method. And the first method is to sit here and add x squared to both sides, leaving us with 11x squared. And then they want to also subtract 99 from both sides, leaving us with negative 99, equaling 0. From there, we can divide both sides by 11. So this divides this by 11, leaving us with x squared, and this divides 99 by 11, leaving us with 9, still equaling 0. And then from there, we're able to factor because these are smaller numbers and they're easier to factor. So that leaves us with x plus 3 and x minus 3 equaling 0. Therefore, knowing that x is equal to negative 3 or positive 3. So this equation may also be solved by extracting the square root of each number, which we will now go over. So that was method 1. Method 2 extracts the square root. It's going to start off the same way with adding x squared to both sides, leaving us with 11x squared equals 99. And from there, we're going to divide 11 by both sides, leaving us with x squared equals 9. And from there, we're going to square root both, so that x equals positive or negative 3. So like I said, there's two different ways of solving these. We use whichever one is more comfortable for you, and whichever one you're more likely to use when pressured on the test. Strictly speaking, in taking the square root from this one here, from x squared equals 9, we may have the sign positive or negative before the square root of each member. That is, we would have positive or negative x is equal to positive or negative 3. This would mean first that positive 3 is equal to positive 3. Positive x is equal to positive 3. Second, that positive x is equal to negative 3. Third, that negative x is equal to positive 3. And fourth, that negative x is equal to negative 3. Since, however, the third equation may be derived from the second and the fourth from the first by multiplying both numbers by negative 1, the first two expressions express all values of x. To check this, we can substitute each value. For the first one, we can substitute each value in the first equation as usual. So we can take negative 3 and plug it in, or positive 3 and plug it in. Or for the second one, we can check the results by solving the equation graphically. So you could plug it into a graph and solve it that way, whichever way is easier for you. Let's do another equation. So if we want to solve the equation 3x squared equals 24, we can solve this quite simply by dividing both sides by 3, getting x squared is equal to 8, and then square rooting both of these to get us x is equal to positive or negative square root of 8. And then from there we can expand that down so that x is equal to negative 2 square root 2, or positive 2 square root 2. And then you would check these as well. Our third equation to solve is 2x plus 1 times 2x minus 3 equal to 2 times 5 minus 2x. So for this, we're going to go ahead and FOIL these so that they are now 4x squared minus 4x minus 3. And then we're going to multiply 2 into this so that we end up with 10 minus 4x. And then we can go ahead and start combining terms and solving. So we can add 4x to both sides, which would cancel them both out, leaving us just with 4x squared minus 3 equals 10. Then we can add 3 to both sides. So 4x squared equals 13. And from there we can square root, leaving us with 2x squared equals the square root of 13. 2x equals the square root of 13. Then we can divide both sides by 2. And the answer is x equals the square root of 13 over 2. To check this, we would plug this back into our original equation and figure out what our answer is. For most of your equations today, you're going to be solving and checking them. Let's go over one or two of your classwork. Let's go over question 4. 3 over 4x squared minus 5 equals 22. So the first thing we can do with this is add 5 to both sides, giving us 3 over 4x squared is equal to 27. And then we can divide both sides. We can multiply both sides by 4 to get us 3x squared equal to 108. And then divide both sides by 3. X squared is equal to 36. Square root both of them. X is equal to positive or negative 6. Alright. Let's do question 6 as well. So we have 2x squared minus 25 equal to 73. The first thing we're going to do is add 25 to both sides. So 2x squared is now equal to 98. From there we can divide 2. X squared is equal to 49. Square root both of them. So x is now equal to positive or negative 7. Alright, so it's not that difficult. It's quite simple. And remember to check all of your equations to make sure that they are coming out to the right answer as it's called for in your classwork. Alright, that's it. Have a nice day.